All right, hope you feel better, buddy. All right, so let's talk about circles. So what makes a circle, right? What's special about a circle? Okay. So, right, it's round, okay.
Does it have any sides?
The definition, it's got no real, it doesn't really have sides, right? It's not a polygon, right? It's curved, So what's like, to be able to define a circle, what do we need to know? A radius, and what else?
Diameter.
The diameter, well, but here's the thing. If we know the radius, don't we also know the diameter?
Yeah.
Just twice the radius. So what else do we need to know? I heard someone else say it. The circumference, again, if we know the radius, we can find the circumference. There's another piece of the circle we need to know. We need to know the radius of the circle, right? The center. You need to know where the center of the circle is as well, okay? And so the definition, geometrically, the definition of a circle, it is, and this is kind of a weird way to say it, but it does work out, right? It's the set of all points, okay, equidistant. This pen is like dying on me here. Let's see. Another. Actually, I'm good. Thank you. Someone swapped all the colors in my pens, and I know who it is. This is gonna be purple, I think. Equidistant to a single point. Yeah, so my pen is red, but it's writing in purple. So that's, I think I know who did that. So a set of all points equidistant to a single point. Okay, and that single point is a point called the center. Okay. Okay. And that distance, right, so it's the set of all points. So if you imagine if I pick a single point right here, if I pick a single point like that, and I come up with all the points that are equidistant to that point. Well, let's say, I could go this way a certain distance, but I could also go this way a certain distance. I can go up, I could go down, I could go kind of like diagonal, diagonal, diagonal. And you can see it kind of like as I add more points, all these points are the same distance, right? And I keep adding points. They're all the same distance from that center, and all these points then would like kind of create the circle, because it would all eventually fill in and create that circle, which I didn't do a very good job sketching there, but you get the idea.
Not drawn to scale.
Okay, right, not drawn to scale. All right, so we call this, so the way we kind of talk about those things is we'll say the circle centered at, and oftentimes it's like O, they use the letter O for the center of a circle, or in this case I'm going to use P. So circle centered at P. Okay. Or you'll see it written this way. This is the symbolic way to write it. We'll put a little circle with a dot in the center, so that way you don't get it confused with an O or anything like that. And we'll put P. So that stands for circle P. Circle with center P.
OP.
Okay? Right. It's OP.
Overpowered.
That's right, overpowered. Geometry is OP. Geometry is overpowered. Okay? So, then, we have some other definitions here, right? So we have, for example, the radius. Okay? So what is the radius? It's the distance from what to what? Okay, what points though? Center.
To a point.
Yeah, to a point on the circle, right? Distance from the center.
To a point on the circle.
Yes, to a point on the circle. Okay, and every time I write the word circle, I feel like it looks like C-I-R-D-E.
Circle.
Yeah, I'll try to make it more. Okay. And then, so if that's the radius, the diameter, okay, you can think of that as like the distance across the circle.
Crosses through the center point.
Right, through the center, exactly right. So it's the distance across the circle. find it again. Through the center. So a diameter has to go through the center of the circle. If it doesn't go through the center of the circle, it's not a diameter. We have another name for that thing. A chord. All right, and so we know also that the diameter is related to the radius. All right, right? So the diameter, so how is the diameter related to the radius? The diameter is twice the radius. So I'm going to put diameter equals 2 times the radius. All right? Diameter is 2 times the radius. Okay. So we'll look at a picture here I'm going to draw. All right. So now I've got a nice stencil that I'm going to use to help me draw some pretty circles. So I got this nice stencil that I got at a art supply store, so I'm going to use that to draw some circles here. Okay. So there's my beautiful circle. Okay. And I'll put in my center there. We'll call this circle P. Okay, so it's P is the center point there. And I'll draw in some other parts. So okay, there's that. And I'll call these points here A and B. And I'll also draw in C. Okay. All right, so Jason, can you give me an example here of a radius that's on the circle? A radius of this circle right here. AP, yep, that's one example. Okay, so radius AP. Now a radius, right, it's a segment. It's got a starting point and a stopping point, right, two endpoints, and it's got a straight line there. So we can actually name a radius using the segment, right? Remember how we drew segments way back in like Unit 1? A radius is a segment, so we can just draw right a little segment bar above it there too. Good. Jason, are there any other radii here? PB, peanut butter. Okay. Peanut butter. Any other ones? PC. Personal computer. Okay. Any more? No, that's right. It's just those three. Those are the only radii that we have.
There's also P.
So, yeah, it just happened to be that way. I don't know. Okay. All right. What about diameter? Let's go to BJ. Is there a diameter here, BJ? AB. That's right. AB. AB. That's right. Okay. So those are the pieces that, you know, we just identified some there. Okay, so AB, right, notice it's also a segment, right? It has a starting point and stopping point of the diameter are on the circle, and it goes through the center, right? It goes through point P. So AB, it goes through point P, right? CP, it's a radius, right? It goes from the center to the edge, but it does not continue through like this, so we can't call it a diameter, right? It's got to be straight. So, okay. All right, let's do a little more here. Talk a little bit more about some vocab. Question?
A radius is so this is if the piece is just like that, do we have a name? Like, does it always have to be like A, P, and A, B?
You for the radius, how you name them?
Yeah, does the P have to be in there?
Yes, exactly right. The radius always has one of its endpoints as the center of the circle. All right.
Maybe like a question like this on a test or something, like get the name.
Like to identify a radius. Yes, I won't ever. I don't think I'm going to ever ask you to like identify all the radii, right? But I'll ask you to identify a radius in a picture or something like that. So you wouldn't have to do all three of them that are here. You could just say just one of them, PC or PA or whatever. All right, so let me draw another picture here for us. All right, we're drawing another circle.
Where you like this one? That's where the...
This will be circle Q. Okay.
Can you ever ask us, like where this point is, what the center point?
Like the location of it and stuff?
Yeah.
Possibly. I'll have to see about that. Possibly, yes. Okay. So there are those points, and let me put one more, and we'll put it right here. Sorry. Okay. I'm going to connect these two.
Like a piece.
All right, so now this is a little bit different. All right, so some of these things we've seen already. For example, right, QR, what could we call that? Radius, right? What about PQ? What could we call that? Radius. What about PR? You could call that what? Diameter. QS, what could we call that? Radius. And PS, what could we call that? Yeah, so is PS a radius?
No.
Okay, so, right, so why is PS not a radius?
Because the center point.
Yeah, it does not include the center point here, right? The radius is always measured from the center to the edge of the circle. So PS, P and S are both not the center, so it can't be a radius. Could it be a diameter?
No.
Why can't it be a diameter?
The center is in the middle.
Doesn't go to the center of a circle, right? So yes, PS here is another kind of segment, and it's exactly what Eli said, if you didn't hear him. It's a chord, C-H-O-R-D, chord, okay, not chord, chord. All right, C-H-O-R-D. So a chord is a segment. Okay, so the definition, you're very careful. Segment with endpoints. Okay, on the circle. Okay, so it's a segment with endpoints on the circle. Okay, so in this case, PS, right? Segment PS is a chord. Okay, segment PS is a chord. It's a segment whose endpoints are on the circle. Okay. Now, believe it or not, in the previous circle that we looked at, there's a chord in this picture too. What is it? So again, the chord definition is a segment with endpoints on the circle. So there's another chord in this picture right here. What is it? So let's go to Alex first.
Couldn't it be AC or CD?
Okay, so but I'm saying, so AC, you'll notice, that would be a chord if it was drawn in. But I'm saying right now, without adding any segment lines in, there's a chord in this picture without having to connect anything. CP? CP is not a chord because C is on the circle, but point P is not on the circle. Oh, you said CB.
Yeah.
So again, CB, it's not drawn in the picture though. You understand what I'm saying? CB is not drawn in. Like there's a segment drawn in here right now without having to add anything that is a chord. Okay? So let's go. Mitch, what do you say? AB, that's right. So AB is not only a diameter, it's also a chord, right? So that means in this picture, okay, we've got PS, which is a chord, right? But what else is a chord here? PR, right? Because it's a diameter. So a diameter is a special type of chord. What's special about the diameter chord? It's it's a chord that goes through the center of the circle, okay? So a diameter really is just a special kind of chord that goes through the center of the circle. That's all. Okay, so PS is a chord, right, because it's got its endpoints on the circle, and PR is also a chord. Okay. All right. Two more new vocabulary terms we're going to look at, and then we'll have one more little problem, and then I'll get you guys started on one assignment. Okay. So we're going to draw one more circle here. Just draw circles all day. There's actually, people have competitions to determine who can draw the most circle-like circle without tools, just their arms, just their hands and stuff like that. And they try to measure, they're able to measure, you know, how good of a circle they drew by hand. How circle-like they did. The technique they use is they actually, and they normally use like a chalkboard or something like that, and they kind of like will hold a marker in their hand and just like take a step and go like whoosh, like that, and then that creates a pretty accurate circle. And there are competitions that people have to draw the best circle. You can believe that. Okay, so we're going to talk about two more vocabulary terms here, and you've heard these words before, or at least one of them. All right, the first thing we're going to talk about is, actually, I'm going to just go ahead and draw this. Okay. Okay, so we're going to draw a line, and what's special about this line is that this line is only going to intersect the circle at exactly one point. Okay? And so this line right here is called a tangent. Now, we've heard that word before, right? Tangent was one of our 3 trigonometry ratios that we had to learn, right? Sine, cosine, tangent. So this is like TOA. And yes, there is a relationship between the tangent of a circle and the tangent trig ratio, even though we didn't really talk about circles when we did trig ratios. We won't worry about that connection right now, but there is a connection there, okay? So anyway, tangent, okay, is a line that intersects the circle okay, at one point. Okay. Now, there's also a special relationship. If I drew, so this point here is called the point of tangency. Okay, it's that special point that only intersects the circle at one point. Okay, and this is a tangent line. Now, if I draw a radius here from my center to this point of tangency, let me draw that radius in here. I'll just go ahead and just draw it in. Okay. How does it look like the radius is related to our tangent line? Do you see a relationship here? There's our radius. They're perpendicular, which means they form what kind of angle? A right angle, and you are exactly right. Okay, there is a right angle here. There is a right angle here between the radius and that point of that's drawn to the point of tangency and the tangent line. Okay, so I'm going to write that here too. A right angle is formed where a radius and the tangent line meet. Okay, so they are perpendicular. All right. Oops, sorry, I didn't realize I was like kind of off the screen. There we go. Okay, a line that intersects the circle at one point is the tangent line, and a right angle is formed where a radius and the tangent line meet. Okay, question, Debbie.
Does it have to be a point, or can it be any line?
It has to be where the radius intersects. It's where the radius and the point of tangency. If you draw a radius to that point of tangency, then it makes a right angle with the tangent line. Yeah, because if you just drew it to like the other, if you drew it to like there, it wouldn't be right angle. It's got to be to the point of tangency. Okay. Last vocab term we're going to worry about for this little piece here, and that's the secant. Okay, the secant, secant, secant line. Okay. And so the secant line is if you just draw another line,
The line that goes through.
but exactly right. It is a line that intersects the circle a line that intersects the circle at 2 points. Okay, a line that intersects the circle at 2 points. So we've got a line that intersects the circle at 1 point, that's called a tangent line. We have a line that intersects the circle at 2 points, that's called the secant line. Can we have a line that intersects the circle at 3 points? That would be, you could, but it wouldn't really work, right? Because it wouldn't be straight line at least, right? You'd have to like draw it crooked or something like that. It'd have to like circle back on itself or something. So no, it would only intersect the circle at 2 points. That's the most we can do for a line.
Center circle is a point, the diameter.
That's true.
3 points.
That's true. Okay, and so with that knowledge, then we can also talk. And I just have one problem for us to try here, and you guys will see here what I'm talking about. So let's just do one problem together, and then I'll get you guys started on your assignment. Okay. So for example, here. Okay, a little example. We'll ask the question: is EF tangent to a circle with center D? Okay, so we'll ask the question: is line EF tangent to circle D? So let me go ahead and draw that in here. Okay. So I'll draw a circle with center D. Okay, I'm going to draw in a tangent, or what looks like a tangent line here, but we got to figure out if it really is a tangent line or not.
How do you figure that out?
And I'll give us some information too, some measurements here as well to help us. Okay, so we'll do that. I'll give us this measurement too. Okay, so the measurement from D to E, which that is a, by the way, what's another name for this segment here? D to E?
Radius.
It's a radius, right? It goes from the center to a point on the circle. From D to E is 11. From D to F, okay, we're going to say, so this whole measurement right here, we're going to say that's 61. And then we'll say from E to F, this distance right here is, we'll say, is 60. Okay. So, given that information, we want to show that EF is tangent or is not tangent. Okay. So, what could we maybe do here? What could we do? We've got a tangent line. We've got a radius right here. We don't really have a name for this segment. The segment DF doesn't really have a name. Okay, or not? I haven't learned a name for it, and I don't think we won't learn a name for it here. But what can we do? How can we determine if line EF is a tangent line here? What's the relationship that we can utilize? Okay. What's the relationship? I'll give you a hint. We talked about this relationship when we talked about tangent lines. So, Eli, you have an idea or no?
Well, what's the triangles related to?
Okay, use what? What kind of triangle would this have to be? If EF is a tangent line, the radius, right here at point E intersecting it, this line and this line should form a right angle, right? If EF is a tangent line. So we can use the, what theorem? Pythagorean Theorem to see if this is a right triangle. If this is a right triangle, that means that's going to be your right angle, and that means we have a right angle between the radius and this line, so it's got to be a tangent line, right? Okay, if you have a right angle here, that guarantees that this line is a tangent line to this circle. Okay, if the radius, right, and the tangent make a right angle, well, sorry, if it's a radius and a tangent, they make a right angle. So let's do that, okay? So let's see here. Pythagorean theorem is a squared plus b squared equals c squared. Okay, so what numbers go where here? So Alex, go for it.
11 could go in that A.
A or B, very good. Uh-huh.
And then 60 will go.
Uh-huh.
And then 61 will go.
And 61 for C. Yep. So let's check it out here. So we'll go to our calculator. 61 squared is 3,721. 60 squared is 3,600. And then 11 squared, is 121. 121 plus 3,600 equals 3,721. Well, let's see here. If I add those two together, 121 plus 3,600 is 3,721. So check. Pythagorean theorem works. And so that means we have a right angle right here. And so then, is line EF tangent to circle D? Yes. Okay. EF, line EF, is perpendicular to DE. Okay. And that's our reasoning right there. Line EF is perpendicular to line D, segment DE. Okay. Questions on any of that?
So, how would you, so what if it doesn't have, if it doesn't have a right angle, then it's not?
Correct. It would not be a tangent.
Okay.
Even if it's drawn to look like it's tangent, Alex, the numbers are what we want to trust.